Okay, so let's take a look at number 65. It says Marissa gets an average of 28 miles per gallon of gas. She plans to drive 200 miles today and 220 miles tomorrow. How many gallons of gas should she expect to use in all? So the first thing we need to do is find out how many total miles she's going to drive. So for number 65, I know it's going to be 200 one day and then 220 the other. So a total of 420. And then I'm going to take the 420 and divide it by 28 because I know that each set of 28 miles I use 1 gallon of gas. So I know that goes in once, and that's 28. I'm going to borrow from him. So that's going to be 4 and a 1, and then bring this down. So 28 goes into 140. So I'm going to estimate that in gallons of gas. So it's 8. And then let's take a look at 66. So this one was a little tricky for some students, and just find out how many square feet I'm going to have. So I'm going to add 3,000 plus 4,200. So 7,200 in total. And so I'm just going to write this. I need to know how many seeds that's going to be. Well, I know that my ratio is going to be 2,400 seeds, and that's going to be, square feet for 40 seeds. So let's just think about what a reasonable answer is. So 2,400 requires 40 ounces of seed. So I know it can't be A or B because it has to be more than 40 ounces. Okay? And so here we could do a couple of things. We could simplify it and find out what it is for one, or we can look and say, okay, what do I multiply 2,400 by to get to 7,200? So 2,400. And again, you could always do your cross multiplication. So 0, 0, 12, 6, 7, yep. So that's going to give me it. So then 40 times 3 is 120. So the answer for 66 is C. Okay, and again, just always check for a reasonable answer so you can eliminate some of your choices. And then you're down to a 50-50, and then back it up with the math. And there's always different ways to solve it. So if you did a different way, that's fine as long as we all got to 120. So this is what this would look like. So what do I know? What do I need to find? So I know his miles is 276 miles. Okay, and that's one way from his house to Los Angeles, and that would be the same going back. And he traveled 62 miles per hour. His trip home, so going back, took 6.5 hours. Okay. How did his speed on the way compare? So I'm going to compare his speed to LA and back home. So I know that his speed was 62 miles per hour to LA, but I want to find out what his speed is going to be going back home. So one of the ways you can do that is you can use your distance equals rate, your dirt times time. So your distance is 276. You don't know what his rate is, that's what you're trying to find, but you know that he traveled 6.5. Okay? So I need to divide by 6.5, divide by, it's going to be 42. So 42 miles per hour. So if I can compare this rate to this, I can look at some of the answers and see which ones fit. Well, I know it wasn't 2 miles faster because 42 is slower. And then 2 miles slower, no, that doesn't fit. Oh, 20 miles per hour faster. 20 miles per hour slower. So we have to figure out which one it was. So how did his speed on the way home? So on the way home, his speed was going to be, it's going to be D, because it was 20 miles per hour slower. And when an object hangs from it varies directly with the weight, which would make sense. More weight, the string's going to stretch more. So it's going to stretch for 2 centimeters when it's a 50-gram weight. But what about if we have, see, if it goes 5 centimeters, how much weight is that going to be? So not necessarily a pretty proportion, but close. So let's just go with close and see what happens. So 2 centimeters for 50 grams means that 4 centimeters, I'm just going to double it, would give me 100 grams. So the only answer that's close to 100 is C. The other way, again, you could do it is to do your cross multiplication. Or you could simplify this down. So 1 centimeter is going to give you 25 grams. So then 5 centimeters, how many grams is that going to be? Well, 1 times 5 gives you 5. So 25 times 5 gives you 125. Okay. So your answer is going to be C. Not for 1 hour, it goes for 2 hours. Okay. So I'm going to find this distance right here. And then my other proportion is going to be 30 miles per hour. But I'm going to be traveling for 3 hours. So these are kind of nice proportions because I could say, oh, 1 times 2 is 2. So then 45 times 2 is 90. And then 1 times 3. And then 30 times 3 gives you 90. But it's asking the total number of hours. So A and B can't be the choice. But 90 plus 90 is 180. So again, your answer is C. And then looking at, let me just go ahead and, so my goal is to go from centimeters, and I want to eventually end up with millimeters. So how I can get rid of this centimeters is I know that for every 1 centimeter, that's going to be 10 millimeters. Okay? So then this divides out, and I'm left with 20 times 10, which is 200. So again, another C. Drawing of this office, 1/2 of an inch represents 3 feet. And again, that's going to depend on what the space is. So the width of the scale drawing of the office is 2 inches. What's the actual width in real life? So one of the things that I like to do is that if it gives me 1/2 of an inch, I'm going to find out what it is for the full inch. So 1/2 of an inch is 3 feet. So 1 full inch is going to be double that, 6 feet. Okay. So then I can set up my proportion. 1 inch is 6 feet. But in my drawing, it's not 1 inch, it's 2 inches. So that's going to give me, 1 times 2 is 2. That means that 6 times 2 gives me 12. So that's going to be D. It says, Mr. Gray is planning to fly an airplane from Smithville straight to Sandia. So 1 inch to 40 miles. So this is kind of like the road trip that we did, where you want to find out what your actual distance is going to be in real life. This is what we would call finding the distance old school. So 1 inch, so 72, that's going to be the left side of our proportion. Technically, it doesn't matter. I'm just writing it down on the left. So I don't have 1 inch, I have 1.5 inch in my drawing. So I want to know what that would be in real life. So kind of a pretty proportion. You could just multiply 40 times 1.5. Okay, if I was to use my cross product. So x is going to equal to 40 times 1.5. And that's going to equal 60. So 60 miles. It's going to give us C. It wants us to know which printer is the fastest. So if you can see that the units are different, so we need to either change them all to seconds or all to minutes. So one of the things that a student did is they just kind of went through and used their logic. So 2 pages per second, that's pretty fast. So if that would mean that for a whole minute, because there's 60 seconds in a minute, that would be 120 pages. The next one is 1 page every 2 seconds. Okay, so I know that 1 second then would be half of a page. So that one, I know that one's going to be slower than the RoboPrint. Now, 160 pages in 2 minutes. That would mean that it would be 80 pages in 1 minute. Okay? And if I was to do that for 1 second, that it's going to be 1 and a little bit more page. So still not at the 2 pages per second. And then the same with this. So 1 minute or 100 pages every minute means that 100 pages, like 1 page and a little bit extra per second. So again, still not close to the 2 pages per second. So 73 is A. Now, for 74, you're going to use your proportion. It says the atmosphere normally exerts a pressure of about 15 pounds per square inch. So how much pressure does the atmosphere exert on a surface of 30 square inches in area? So I'm going to set this up. So 15 pounds for 1 inch. But I don't have 1 inch, I have 30 inches. Okay? And how many pounds is that going to be? Oh, well, if I use my cross product, I can just cross up, and 30 times 15, you can look at here, 1 times 30 gives you 30, so 15 times 30. It's all the same math, it's just the way you look at it. So I'm going to go ahead and multiply 15 times 30. And let's see, 0, 15, so 450. So 450 pounds D. 75. A utility company estimates that a power line repair job will take a total of 24 person-hours. If 3 workers are assigned to the job, how long will it take them to complete it? So 24 person-hours means I would need 24 people to work on it for 1 hour to get it done. So I can just divide. I don't have 24 people, I only have 3. So that's going to take them 8 hours. And that is A. And then for 76, citizens of Honduras use Lempira for their money. In July 2010, the conversion rate for U.S. money to Honduran money was about 6 cents for every 1 Lempira. And your conversion rates will change depending on the time and the country that you go to. So what dollar amount is equivalent to 300 Lempiras? So first thing I'm going to do is set up a proportion. So 6 cents for 1. Okay. How much money is that going to be for 300? Okay, nice proportion. Oh, 1 times 300 gives you 300. So 6 cents times 300. And you can do 3 times 6 would give you 18. Okay, so then you know it's going to be $18. And again, if you want to do that old school, you can. So it's 0, 0, 18, and I have 1, 2 decimal places, 1, 2. So 76 is C.